Alright, we're going to look at leveling the bed today on our Ender style printer. We got this one over here. This is the one that we are using for the class in the winter quarter. It's working. I've already printed out one test print for a test of a bed level. We do have to make a couple of clarifications, I guess, on what different things mean. First of all, we're not actually leveling, like getting out a bubble spirit level type thing. We're not doing that sort of leveling. What we're doing is closer to what would be called tramming on a milling machine or something like that, where what we need to make sure is that the surface that we're printing on, this bed that moves back and forth, is square, perpendicular, parallel, you know, whatever the axis might be to our printing mechanism here. And so it doesn't really matter if the bed itself is level according to a level, if the machine is not level, and if the track that the bed moves on is not level, and all of those sort of things. So it's not really that we're leveling it, we're just squaring everything up so that when we print a part, the print head will always be the same distance from the surface that we're printing on, no matter where it's at on the surface, and that the part that is printing square to the print bed. It's not skewed in some direction. You can imagine if this piece here was not perpendicular to this piece, then the resulting part would be kind of a rhombus shape if you were trying to print a cube. You know, it would be skewed. Or if this axis that the bed rides on is not perpendicular to these uprights in the Z direction, then we'd have some weird shaped skewed parts also. So I am assuming that when you built your printer, you did your best to get these perpendicular to one another, this axis parallel to this bed, or at least, you know, perpendicular to these. We're working on the parallel part right now. Get this axis. This axis usually comes assembled on your printer already, so you may not have even thought to do anything with it, but it's possible that it is not perpendicular to these vertical pieces also. So all of those kind of things are things that you should do ahead of time when you're assembling the printer. Sometimes that means taking things apart and reassembling if they're really out of whack. I did have a printer last summer, I believe it was, where this piece just was not the way the parts were cut. There's a little notch cut down under here that it sits in, and the way it was cut, it just wasn't going to be square with the rest of the printer. So I did have to do some shimming and things like that to get this axis to be perpendicular to our Z axis. So all of that being done, what we're actually going to do is we're going to level this bed. We're also assuming that the bed is flat. It could be that the bed itself is warped, bowed, bowled, you know, cupped. It could be all kinds of different shapes that aren't flat. That we can't really take care of with this. We're just going to try and average out the flatness of our bed the best we can. Hopefully you have one that is already flat. There are things you can do. You can add glass to this. You can replace this. Probably the simplest way, if you have a warped bed, is to take you some aluminum foil, thin sheets of aluminum foil, and place them under the low spots. So in this case, this, you know, this surface will remove. This top surface is not attached to the aluminum beneath it. It's not glued down or anything like that. And you can take some aluminum foil in the low spots and place them between the two, and you can kind of level it out that way, assuming that you can clamp this down enough to actually push the foil down and have it make a difference. You want to use aluminum or something like that because you still want to transmit heat, and aluminum is good at transmitting heat from the heater, which is underneath this bed, to the top surface. So I'm assuming that this is flat. I haven't actually checked if it's flat or not. I did print this, and it did print, although I can see from this print that it's not quite level just yet. Let's look at closer at what is on here and see if we can diagnose what might be the problem. All right, so let it zoom in there. So these actually look a little bit okay. These over here, it's going to be hard for you to tell. Well, maybe if I move up where you can see more at once. There we go. So you could pretend or imagine that this is discolored, you know, this is a different color from this one just on the camera, but it's actually not. These are different colors because of their thickness. And so these on this side are a much lighter color than the ones on the other side over here. And that's because they're squished down a lot more. These three are really too thin, so you can see through them really well. Now this filament I'm using is a little bit transparent, and this is only one layer anyway, so it's going to be transparent. But when you compare to maybe these over here, you can definitely see a color difference. Actually, these over here, we're going to have to get close to them to see what's wrong with them. So let's get close to this one. It's a good example. Where'd it go? There it is. So it's at the top of the screen. I can't really get the camera. There we go. See how there are gaps in it? So little gaps between there. It's not completely filled in. This one is too high off the bed, so it wasn't squishing the filament enough. So this side, which is the right side of my printer bed, it's kind of weird on the camera here, the way that's all turned around. But it's actually, the bed is too low here because I have these gaps between my print. Right in the middle is pretty good. You know, there. I try to get the. Let's turn the camera off, the light off. There we go. It's not squished down too much. It's a little bit high, like as far as the nozzle from the bed, the distance is a little too large, but not much. I would say, and I don't know if I can get a picture of this one, but this back here, this is actually the back of that same row, the middle row. That's more like exactly what you're looking for. You can kind of see right in here, this area is a little bit uneven, but that's pretty good. That if you could have them all, the entire bed, print with that level of completeness, so there's not little gaps in it, but it's also not squished to the point that it's going to have a hard time scraping it off of there, then that's probably what you're aiming for. These over here, these are going to be actually too close, and probably you can see the difference. I don't know if it's easy to see on camera or not, but in person it's relatively easy to see. These did print, but they are very thin, which you might think is good because it squished it down to the print surface, and it's probably not going to release during printing. So that part of it's good, but what will happen when you squish that first layer too much is that you'll get the bottom of your part bulging out. So it's called elephant's foot. You know how an elephant's foot is a cylinder and then it bulges out at the bottom? That's kind of what will happen to all your parts. And they'll be a little bit shorter than they need to be, and the bottom will be a little bit wider than it needs to be. So it can create problems with fits if you're trying to fit parts together. Also, it can create problems with trying to remove it. Let's see how easy it is to remove this. Having a hard time getting underneath it to scrape it up already. See if we can get this under there. All right, so let's see what we have here. I started this corner peeling up a little bit. So these, the ones that were really high, pull up really easily, which is not a problem. They were actually probably okay. There's just a little bit of gap in them, so they're a little bit too high, meaning the bed is too low. The nozzle was too high. These are about right, what you would want. And this, I guess this is a build tack like surface here that came with the Ender 3. It actually works pretty well as far as holding these parts down, or these prints down. I may have to go off camera and come back to getting this thing off of here. Let's see. I wanted to peel. Here we go. All right, so here's some of these. Notice how it's really hard to peel these off. That can be a problem sometimes, particularly when it's really thin like this. It's hard to get any kind of underneath there to peel them off, and it can end up messing up your bed. Although there it did go. There we go. So I would say that the ones on this side were a little bit too close. The ones in the middle were the way I like them anyway, where it does stick, but it's not impossible to remove, and it doesn't deform the bottom of the part too much. These over here, well, you can't see what I'm pointing on that one. The ones that were over here on the right-hand side, they were a little bit too high. I would not I would be worried about them peeling up during the print sometime. That would be a possibility anyway. So how do we get to that point? How do we level this thing? So one thing I could do is I could just take that information from that print and say that, well, this side over here, the left side, it needs me to lower the bed a little bit. So there are knobs underneath here. Let's see what kind of picture I can get. There's the edge of one. There's knobs here that I can tighten. There's a little screw in there that I can compress and lower that. And this side over here was the part that I printed was a little bit too high. You know, it's a little bit the nozzle too high from the bed. So I might need to raise this side. So I got to turn the knob on this side. There's knobs on each corner here for this particular printer. And I can adjust that height that way. That's one way you could do it. Let's look at the part I got and printed, you know, this thing, and how you would set that up. So here we are in Cura. This is the very newest version. I just had a pop-up that said there was a new version, so I downloaded and installed it. So if you go to Cura, I guess it's Cura.com. I actually don't know the download site for it, but if you search for Ultimaker Cura, Ultimaker is a company name, and they make their own line of printers, but Cura is a print slicer that will work with almost any FDM printer you can imagine. So it is free. It's open. I don't know if Ultimaker Cura is open source, but they have branded their thing on top of Cura. Anyway, you can get it for free. So I have added. So if you go to this marketplace over here, I have added an extension. Let's see if I can actually get it to do this. Sometimes the marketplace is a little bit slow, but well, they call it a plug-in on this one. And let's just look at the installed ones. Actually, I've installed 2 here, but the calibration shapes. This is a good plug-in to add to Cura to get a quick way to print various pre-made geometries for different calibrations you might want to do. So I did that, and you can get it from the plugins. Just search for 5-axis calibration shapes and install it. It's also free. You might have to create an account for the marketplace, possibly. I don't remember. All right, let's wait for it to come back. Apparently, closing the marketplace gave it some trouble there. I don't know exactly when it'll wake up. Maybe we'll just start a new one here in a second. There it goes. All right, just had to wake it up. All right. Although it's hung up on something, the marketplace hasn't closed yet. There we go. So extensions, it'll show up as part for calibration once you install that plugin. And then there are several in here. One of these was a bed level calibration. Add a bed level calibration. So you click on that and it will add that pattern in there. We'll have a whole nother video on how to go through and use a slicer and set it up and everything. So I assume that you at least have done that part, at least the basic part. You've added your printer in over here. Add printer, and you've added an Ender 3 or whatever you have for your printer. This version of Cura does have a lot of pre-built profiles where you don't have to go and type everything in yourself. You just have to add the one that you have. We're using just some generic PLA. There are different materials in here. Printers just has a Matter Hackers, I think, might be the brand that's on there right now, PLA. And it's a 0.4 millimeter nozzle. These are all your default settings over here. 0.2 millimeter layer height, which is pretty standard. Infill, which doesn't matter on this one. And then you slice it and print that. So that was the result of what we just looked at, was this. All right, so if you want to check to see if you're at least close to level before you start printing, maybe you can't even get a print to stick down to check to see if it's too high or low. What you want to do is, first of all, go ahead and prepare on your menu over here. Let's get back in the line of where we can kind of see stuff. So I'm over here, prepare, preheat. This is PLA, so preheat PLA. you want to preheat the end, so the hot end and the bed. Both of these are metal. You know, the bed is aluminum with some stuff on top of it, either glass or this print surface here, whatever, but it's metal underneath, and the nozzle and the hot end is all metal, or at least mostly metal, with maybe a Teflon tube in the center of it. And what happens to metal when it heats up is it changes shape. So you want to go ahead and preheat both your hot end and your bed surface to printing temperatures before you try to do the leveling process. Otherwise, you'll get it all one way with it cold, and then when you go to print, it all changes shape when it heats up. It deforms under the thermal load of the heated bed and the heated nozzle, and it's not the same shape as what you started with. So you want to heat everything up first. And one thing that can happen here when you are heating up is you could have filament ooze out of the nozzle tip. And if there's a little bit of filament hanging out of that nozzle tip, when you go to level, we're going to actually try and level this by measuring the distance between the tip and the surface one way or another. I'll show you how I'm going to do it. But if that little piece of plastic is hanging under there, it will change that distance, and so you want to make sure the nozzle tip is clean. I usually use, I don't see it right now. Oh, here they are. I usually use some of these to go in there. Just, you know, get that little bit of plastic that's usually oozed out. Get that out of there so that it's not interfering with our measurement. So we're heated up. Prepare. I want to home all the axes now. Axes. So I want it to know. I want it to figure out where it thinks all the 0 points are. And oh, got some boxes in the back here that are in the way. All right. So once it moved everything back here. There we go. Well, let's get further away. Get a more general view of what's going on. This is what was in the way. We'll look at that sometime later. This is a scanner, a little handheld scanner for scanning geometry. All right. Now what I do, so some people use a piece of paper, which is fine. What I'm going to do is I'm going to find a metal object that I know the thickness of. So I've got one object handy. So if you have like gauge blocks and that sort of thing, then they would be the ideal thing to use, but I'm assuming that most people don't have something like that just sitting around. So what I have, and maybe you don't have this sitting around either, but we'll look in our little set of dice here, and I've got one, at least one anyway, that's metal. I want a metal one because remember, all of this over here, this bed is 60 degrees Celsius and the nozzle is 200 degrees Celsius, so any kind of plastic thing or even wood is going to get charred or melted. So you want something that's not going to happen to. This little guy happens to be, if we get our calipers out, pretty much, I don't know, actually let's zero. Yeah, we're zeroed. So pretty close. Let's get the, yeah, that direction. Pretty close to 16 millimeters thick. So you want something that is measurable. So what I'm going to do is I'm going to raise the z-axis 16 millimeters. So prepare, move axis, move z. In 1 millimeter increments. It currently thinks it's at 0, so I'm going to move it up 16. And clean it off again. It's oozed some more out. So make sure it's all heated up and hadn't cooled down on me accidentally. Yeah, it's still all at printing temperature. And then I'm going to, you could disable the steppers at this point so you can manually move things around by just moving them, but I'm going to use the menu instead of doing that. Whenever you disable the steppers, there's a possibility that you might lose some Z height, and I don't want that to happen. So I'm going to use the menu, prepare, move axis. I'm going to move X over to something like that. Move axis Y. Something like that. Clean off the nozzle again. Make sure that I'm still using the same sides here. These two, the 5 and the 2, were the sides that were 16 millimeters. And just go there, and what I'm trying to feel is that I can move it under there with very little resistance. But right now I actually I can feel a little bit of resistance. So I'm going to back off, meaning that I'm going to compress this spring to lower this corner. There we go. Just like that. You're doing the same thing when you have paper, but what you're trying to do when you level this, what the printer assumes is that you have put it at the 0 point, and the paper is really thin, hard to measure the thickness of the paper, and so raising it up the exact same thickness as the paper is kind of complicated. So I find it a little bit easier to find something that has some amount of bulk to it so that I can get a little bit easier to measure distance there, I guess. And then I'll just do each corner that way. So now I'll move the X over to this other corner. Let's see, 210. Right there, maybe 200. And then we don't have to move the Y. Let's go ahead and do this one. Now, remember this side was too high. I feel hardly any, actually I can't even feel the thing, so I do need to let off a little bit. An important thing, and this is a mistake that some people make even with the paper, is you're not careful about like pushing down on this. If you push down at all on the bed, then you're artificially changing that height, and it's going to spring back. So make sure you're not applying any force downward to the bed when you're doing these measurements or setting these distances. Let's do the last ones here. Let's move Y back to the back. There we go. Check it. Probably shouldn't leave my little block sitting on the bed because it will heat up and it could change shape a little bit. So I'm going to let it cool down. It's a little bit warm. All right, there we go. Yeah, I don't feel anything. So let's get back there. There we go. And then let's do the last one. This is one of the ones that was tight. Well, it's pretty good. There we go. And if you want to, you can check the center point. You know, that'd be around 110. Although this is harder to change because I don't have a support in the middle, but I can check to see. And it is really good. So I want to say that this bed is mostly flat and pretty well leveled now. And there shouldn't be any more changes I need to make until I have done something that potentially unlevels it. One thing that you can do that unlevels it all the time is work too hard on removing your part. So with these printers that have removable surfaces, it's best to take the time to remove the surface off of the thing, then remove the part, versus trying to scrape the part directly off of here, because you do run the chance of getting the bed all out of level by scraping and pushing on the build surface while your part is on there to try and pop the part off of there. So that's the leveling the bed procedure that I use. It works pretty well. It does assume that the bed is flat to begin with, which is not always true. If you find yourself with a bed that's not flat, either purchase one of the glass bed surfaces that you can just put on top of these. That will be one way to do it. Or find a sheet of glass. The first printers that I used, I just used a sheet of glass from a picture frame and cut it down to size and used that, and it was fine. But glass and the mirror surfaces are generally pretty flat, and you can usually get those to even out some of the warpedness in a bed that might be a little too warped. Do realize if you put more stuff on top of this bed, you'll probably have to increase your heated temperature for the bed because it's got more insulation now to get the heat through to get to your part. So if you were printing at 50 degrees Celsius on the bed and you add a big piece of glass on top of it, you might have to go up to 60 degrees Celsius to get the same effect. Anyway, we'll come back in a few days with another video on some of these basic things that you have to be able to do to get your prints to work out.